Hello, welcome to this lesson on our study of calculus 1, and particularly in differentiation, especially differentiating from first principle. Okay, so if you have not subscribed to my channel, kindly subscribe to support the channel as well. Okay, all right, let's start. So we are supposed to differentiate from the first principle these two functions. Okay, and indeed, if you're able to differentiate the two functions from first principle, we can use it to do differentiate every trigonometric function. Okay, we'll talk about them later. Okay, but let's try to try to differentiate from the first principle using these. Okay, now the first thing to tackle is f of x equals sine x. Okay, if you remember, we said that from the first principle, this is what you use limits as h approaches 0. Okay, h approaches 0 of f of x plus h minus f of x over h. Okay, now with this, since we have sine of x, we'll get sine of x plus h minus sine of x. Okay, so let's try to go ahead, and before we start this, let's try to draw write some identities down here, because those are the identities we are going to use. Okay, so that sine a plus b, okay, is equal to sine a cos b plus sine b or cos a. You can start with that. Okay, let's start with cos a sine b. Okay, and we know that sine a minus b, okay, we are writing for both sine and cos, so it's equal to sine a cos b minus cos a sine b. Okay, now with these two functions, if I try to subtract them, okay, if I try to subtract these two equations, I'll get sine of a plus b. I'm trying to show you the way. Okay, so kindly just stay tuned and look at the way I'm doing this, because when I subtract the two of this, I'll subtract this and this, and I'll get 0. When I subtract them, I'll get 0. Okay, because they are the same thing. But this will give me cos a sine b minus cos a, so it becomes 2 cos a sine b. Okay, now with this, I know that when I do this is equal to that. Okay, so let's try to do something here. Okay, sine of something minus sine of something. Why don't you combine the a plus b and call it like a p, and call a minus b a q, so that when in the first principle we get sine of something minus sine of something, we use these identities to solve. Okay, so you call these two simultaneous equations. So when I add them, when I add these two equations, let's say this is equation 1, this is equation 2, when I try to add this, I'll get 2a, that is a plus a, then b minus b or b plus minus b will give me 0. So I have p plus q. So I have a being equal to what? P plus q. All right, I hope you are seeing what I'm trying to do here. Now when I subtract the two equations, a minus a will give me 0, b minus b will give me 2b, then I'll get p minus q. Okay, so I have b also equal to p minus q over 2. Okay, so now let's come and put a plus b is what? P here, and a minus b is what? Q. Then we put a and b in place of wherever we see them. Okay, so it means that we'll have to get sine of p, which is a plus b, minus sine of q, which is a minus b. Okay, sine of q is now equal to, now I go to 2 cos a. Okay, 2, then cos of a is what? P plus q over 2. Then sine of b, which is p minus q over 2. So let's keep this identity that whenever we have sine of something minus something, this is how it goes about. Okay, I hope you can see this clearly. Now let's do it for cos, and after that, trust me, you will be able to solve every question and the first principle using the cos and whatever that we know. So with the cos, you know that's cos of a plus b is also given as cos a cos b minus sine a sine b. Okay, we'll actually treat trigonometries. Okay, so don't worry, stay tuned. As you follow us, we'll do it and you understand these. Okay, then cos of a minus b is also equal to, cos a cos b plus sine a sine b. Okay, so let's try to subtract these as well. Okay, so and have cos of a plus b minus cos of a minus b, okay, is equal to minus sine. So have this minus this will give me 0 automatically. You know they are the same, but minus sine a sine b minus sine a sine. So I have minus 2 sine a sine b. Okay, I hope this is okay. So if you remember, we've already proven what a plus b is and a minus b. So a plus b we said is what, p minus cos of q, and this equals minus 2 sine of a, where a is what, p plus q over 2, and sine of b, which is also equal to p minus q over 2. I hope you get this. So we are coming to use these two. This is the other one we are coming to use, this one. Okay, because in the cos on, that is from the first principle, the cos on will get cos something minus cos something. So keep these identities, we will refer back to them and use them. Okay, so let's start with the first one. So this is what we have. So we know that f of x plus h will be equal to sine of x plus h, because we have only sine of x. Okay, so now with this we have limits, which that is, we want to differentiate this. We'll have limit as h approaches 0 of f of x plus h. We are quoting this formula. Okay, so f of x plus h is what, sine of x plus h. Okay, s plus h minus sine of what, x over h. Okay, over h. Now we have, if you let p be equal to x plus h and q be equal to x, we have sine p minus sine q. Okay, I hope you can see what I'm trying to say. So we know that sine p minus sine q, so we mean sine p minus sine q. Okay, we know it's equal to, you go to this thing and then quote. Okay, it's equal to that. So you have 2 cos of p plus q over 2 sine of p minus q over 2. Okay, so since we know p is equal to x plus h and q is equal to x, then you can also put them there and know what to do. Okay, so we have limits as h approaches 0 of sine of whatever that is there, this minus this, and said now p and q are going to change to s plus h, because it's sine of something minus sine of something, and this is indeed sine of something minus sine of something. This is the relation we use. Okay, so we'll come and put it here, 2 cos of, now p is x plus h plus q, which is x over 2, then sine of p, which is s plus h, minus q, which is x over 2, all of these over h. Okay, all right, I hope this is okay. So now this limit as h approaches 0, okay, then 2 cos of 2x plus h over 2, then times sine of h over 2. Okay, now we are saying as h is approaching 0, so it means h is very, 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 very small. Okay, h is approaching 0 means that h is very, very, very small. So it means For small angles in trigonometry, for small angles, okay, sine of theta is equal to theta, where theta is in radians, okay. So it means that as h is approaching 0, it means h is become very small, and sine of h over 2 will also be very small because h is already small. We are dividing it by 2, it means it will be very, very small. So for small angle, sine of h is approximately equal to h over 2, okay. So this is an approximation, okay. So therefore it means that the whole of sine of h over 2 tend to be h over 2, okay. So we'll have limits as h approaches 0 of 2 cos 2x plus h over 2, then sine of h over 2 tend to h over 2, all divided by h, okay. All of the whole of this is divided by h, if you remember. So now this whole thing will be limit as h approaches 0 of 2 cos 2x plus h over 2 times 1 over h. Sorry, it's h over 2. H over 2 has to come first, okay. H over 2 times 1 over h, okay. So therefore this can take this off, okay, and we'll have this 2 taking this 2 off. I hope you can see this, okay. I'm very sure that you'll be able to see that it's just half times the whole of that, and that 2 can go. So we have limits as h approaches 0 of cos of 2x plus h over 2. So now we can put our h equals 0 inside this whole expression, okay, and we'll get something like this. Cos of, so the limit, everything is equal to cos of 2x over 2, okay, it's like this, plus 0. This will be equal to cos of 2x over 2, and this will be equal to cos x, okay. So it means when f of x equals sine of x, f prime of x, which is the derivative that we just saw, is equal to cos x. Indeed, if you have proved this, and if you use other methods, that is true, okay. So let's talk about the next one, which is f of x equals cos x, and we'll be done for the video, okay. All right, so with this, we said we'll use limit as h approaches 0 of f of x plus h minus f of x, okay, over h. Now you know that f of x plus h for cos will be equal to cos of s plus h, okay. So now let's put them here. You have limits as h approaches 0 of cos of x plus h minus cos of x over h, okay. Now with this, if you remember, we said that cos p minus cos q is actually equal to what? Minus 2 sine p, okay, p plus q over 2 sine of p minus q over 2, okay. So we can refer it back and see if what you are saying is true, okay. Indeed, it is true. This is what we have here, okay, the down one. I hope you can see it. So that is what we have here. So here we assume that, or we put p equals x plus h and q equals x. Then this will be very simple for us to do, okay. So it means we'll have limits as h approaches 0 of, now we have cos something minus cos something, okay, and that we are coming to use this expression here. So we have minus 2 sine p is what? X plus h plus q, which is x, over 2, then sine again s plus h minus x over 2, then all over h, okay. I hope you get this. So let's try to do this. Let's go ahead, and this will give us limit as h approaches 0 of minus 2 sine of 2x plus h all over 2, then sine of h over 2, okay, all over h. Now, if you remember, we said that for very small angles, sine of theta is equal to, or is approximately equal to theta. So it means sine of h over 2 will be equal to h over 2 for very small angle, because h is approaching 0, so h is very small, okay? I hope you get this. I hope that is okay. So it means that we'll have something like this: limit as h approaches 0 of minus 2 sine of 2x plus h over 2 times h over 2, all divided by h, okay? And if you continue simplifying, this h here can take this h out, and this 2 can take this 2 out. So I'll be left with limit as h approaches 0 of minus sine of 2x plus h over 2, and here I can insert my h equals 0 here, so I'll be left with minus sine of 2x plus 0 over 2, okay? And this will be equal to minus sine of x, okay? So it means when x equals cos s, the derivative here will be equal to, okay, you don't have a space here, so let me write it here. When f of x equals cos s, what we just found is that the derivative f prime of x will be equal to minus sine x, okay? So these are the only things we need to know, that when f of x is also equal to sine x, f prime of x from first principle is equal to cos x. So once you know this, we can find the derivative of every trigonometric function, because we'll use some rules and regulations governing differentiation to solve the rest of them, okay? So you don't need to use first principle to solve all of them. You can use some rules. Once you've been able to use first principle to find this and this, we'll use what we call the quotient rule, product rule, and the rest to solve for the rest, okay? All right, so thank you, and don't forget to subscribe to my channel. In our next discussion, we'll talk about the rules and the easiest way to solve this differentiation without going through the first principle. See you next time.